Here we're looking at the difference of squares rule, where you got a squared minus b squared, a squared and b squared are both perfect squares, and we can rewrite it in this factored form right here. So what we're going to do is take this example, n squared. So a squared is n squared, so a is the square root of n squared, which is n, and b is the square root of 25, 5. So if we write this in factored form, we get n plus 5 and n minus 5. There's my factored form. If we move on to the next example, we've got 4x squared minus 81. 4 and 81 are still perfect, or 4x squared and 81 are still both perfect squares. So the square root of 4x squared is 2x, and the square root of 81 is 9. So we get 2x plus 9 and 2x minus 9. If we wanted to check our answer, we'd multiply that back out and find that we get 4x squared minus 81. Something that looks like this is still difference of squares. X to the fourth is x squared times x squared. 16 is 4 times 4. So we can write that out as x squared plus 4 and x squared minus 4. Now, x squared plus 4 is fully factored, but this is here still follows the difference of squares rule. X squared minus 4, square root of x squared is x, square root of 4 is 2. So we can rewrite that as x plus 2 and x minus 2. We attach the x squared plus 4 to the front, we get our final factored form. Now we got the sum of cubes rules. We need two perfect cubes. If they're added together, we use this factored rule. We'll figure out what a and b are, and we can just plug them in. So a would be the cube root of x cubed, which is x, and b is the cubed root of 8, which is 2. So if we plug it into the form, we get x plus 2 times x squared, because we've got a squared, minus 2 times x, a times b, so x times 2, minus 2x, plus 4, which is 2 squared. There's our factored form. Factoring by the rules is easy. You just need to figure out which rule you're using at any one time. Even something like this is factorable by the sum of cubes rule. So here, the cube root of x cubed y cubed is xy, and the cube root of 64 is 4. Plugging it into the rule, xy plus 4 times x squared y squared minus 4xy plus 16. Same thing, now, but we've got the difference of cubes. So this time I'm subtracting instead of adding, and notice the rule changes a little bit, but it's the same setup. The cube root of x cubed is x. The cube root of 125 is 5. So we get x minus 5 as the first factor, and x squared plus 5x plus 25 as our second factor. Finally, we've got this here. This is a difference of cubes. It's also a difference of squares, and that's where I'm going to start with this one. So if I'm starting with the difference of squares instead of the difference of cubes, the square root of n to the 6th is n to the 3rd. And the square root of 729 is 27. So I can rewrite this using the difference of squares as n cubed plus 27 and n cubed minus 27. Now, these are now sums and differences of cubes, so we're going to use those two rules. If I use the sum of cubes here, I'm going to get n plus 3 times n squared minus 3n plus 9. And if I use the difference of cubes rule here, I'm going to get n minus 3 and n squared plus 3n plus 9. So my final factored form is all of this.